Imagine a universe so vast and strange that even our wildest imaginations barely scratch the surface. A universe teeming with more stars than grains of sand on all the beaches of Earth. A universe where black holes warp the fabric of space and time, and the faint echoes of the Big Bang still resonate. Today we're diving into mind-blowing facts about our universe, secrets and discoveries that will change the way you see everything. We'll journey to the farthest reaches of the cosmos, exploring the unimaginable distances and mind-boggling phenomena that make our universe so captivating. Our home, planet Earth, seems vast and expansive to us, but it's just a tiny speck of dust in the grand scheme of the cosmos. Imagine shrinking our sun, a star 1.3 million times larger than Earth, to a grain of sand. On this scale, Proxima Centauri would be another grain of sand 4 miles away. And that's just our cosmic neighborhood. The Milky Way contains hundreds of billions of stars across 100,000 light-years. But the Milky Way is just one of billions of galaxies in the observable universe. The universe is not static. It's in a constant state of expansion. Imagine a loaf of raisin bread baking in the oven. As the bread rises, the raisins within it move farther apart from one another. Similarly, the galaxies in our universe are moving away from each other due to the expansion of space itself. This expansion was first observed in the 1920s by astronomer Edwin Hubble, who noticed that the light from distant galaxies was stretched, or redshifted. This redshift indicated that the galaxies were moving away from us. Furthermore, Hubble discovered a relationship between a galaxy's distance and its redshift. The farther away a galaxy is, the faster it appears to be moving away. This observation suggests that the universe is not only expanding but also doing so at an accelerating rate. Something, a mysterious force we call dark energy, seems to be counteracting gravity and pushing everything apart. Think of dark energy as an invisible force field permeating all of space. We don't know what it is, but its effects are undeniable, driving the accelerating expansion of the universe. The sheer number of stars in the universe is truly mind-boggling. To put it into perspective, imagine holding a handful of sand. Now picture all the beaches on Earth, every coastline covered in countless grains of sand. Astronomers estimate that there are more stars in the observable universe than all the grains of sand on all the beaches on Earth. That's a number so large it's difficult to even comprehend. To give you an idea, there are roughly 100 billion trillion stars in the observable universe. That's a 1 followed by 22 zeros. To make it even more relatable, that's about 100 billion stars for every human being on Earth. Each of these stars is a giant ball of hot, glowing gas, many times larger than our own sun. And many of these stars have their own planetary systems, just like our own solar system. The next time you gaze up at a starry night sky, remember that you're looking at just a tiny fraction of the incredible number of stars that exist in our vast and awe-inspiring universe. When we think of planets, we often envision them orbiting a star, bathed in its warmth and light. But not all planets are so fortunate. Deep within the vastness of space exist rogue planets, celestial nomads that drift through the galaxy without a star to call their own. These rogue planets, also known as interstellar planets, were likely ejected from their star systems during their early formation, flung out into the depths of space by gravitational interactions with other planets or passing stars. Imagine a planet, perhaps similar in size and composition to Earth, hurtling through the frigid darkness of interstellar space. With no star to provide warmth or light, its surface would be a desolate, frozen wasteland. But even in this extreme environment, some scientists believe that rogue planets could potentially harbor life. Deep beneath the surface of a rogue planet, geothermal heat from its core could provide enough energy to sustain liquid water, a key ingredient for life as we know it. Looking up at the night sky is like peering back in time. The light from distant stars and galaxies takes time to reach us, so we see these objects as they were in the past. The farthest galaxy we've ever observed, called GNZ 11, is so distant that the light we see from it today began its journey towards Earth an astounding 13.4 billion years ago, just 400 million years after the Big Bang. This means that we are seeing GNZ 11 as it existed in the universe's infancy, a time when the first stars and galaxies were just beginning to form. Imagine the universe in its infancy, a chaotic sea of hydrogen and helium gas. GNZ 11, a collection of young, hot stars, shines brightly against this backdrop. a beacon from the dawn of time. Studying distant galaxies like GNZ11 allows astronomers to piece together the history of the universe and gain insights into the processes that led to the formation of galaxies like our own. Black holes are among the most enigmatic and awe-inspiring objects in the universe. These cosmic monsters are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Black holes form when massive stars collapse at the end of their lives. As the star's core implodes, its gravity becomes so intense that it warps the fabric of space-time, creating a singularity, a point of infinite density. But black holes are not just static voids in space. They can rotate, and some black holes spin at incredible speeds, approaching the speed of light. Imagine a black hole spinning so rapidly that it drags the very fabric of space-time along with it, creating a swirling vortex of unimaginable power. This spinning motion can have profound effects on the surrounding environment, influencing the formation of stars and galaxies. Chapter 7. The Mystery of Dark Matter, the Universe's Invisible Hand. Our universe is full of mysteries, but perhaps none is as perplexing as dark matter. This elusive substance makes up roughly 85% of the matter in the universe, yet it doesn't interact with light or any other known form of electromagnetic radiation. We can't see it, touch it, or detect it directly, yet we know it's there because of its gravitational effects on the visible matter around us. Imagine a galaxy, its stars and gas clouds held together by the invisible hand of dark matter. Without dark matter's gravitational influence, galaxies would fly apart, their stars scattered into the void. Despite decades of research, the true nature of dark matter remains one of the biggest unsolved mysteries in modern astrophysics. Chapter 8. Parallel Universes, a Multiverse of Possibilities. The idea of parallel universes, once relegated to the realm of science fiction, has captivated the imaginations of physicists and cosmologists for decades. The theory of a multiverse suggests that our universe is just one of many, perhaps an infinite number of universes coexisting alongside our own. Imagine a vast cosmic landscape where our universe is just one bubble in an infinite sea of bubble universes. Each of these universes could have its own unique set of physical laws, constants, and even its own history. In some universes, gravity might be weaker, stars might burn differently, or life might have taken on entirely different forms. While the concept of a multiverse is still highly speculative, it offers a tantalizing glimpse into the possibility that our reality is just one of many. Chapter 9. White holes, cosmic fountains of matter and energy. If black holes are cosmic sinks, swallowing everything that crosses their event horizons, then white holes are their theoretical opposites. Cosmic fountains, spewing matter and energy out into the universe. Unlike black holes, which are regions of spacetime where gravity is so strong that nothing can escape, white holes are hypothetical regions where nothing can enter. Imagine a white hole as a cosmic geyser erupting with unimaginable force, spewing forth matter and energy that were once trapped within a black hole. While white holes remain purely theoretical, some physicists believe they could be connected to black holes through wormholes, hypothetical tunnels through spacetime that could connect distant regions of the universe. Chapter 10. Stardust, the Cosmic Connection. We often think of ourselves as separate from the universe, as observers looking out at a vast and indifferent cosmos. But the truth is far more profound and interconnected. Every atom in our bodies, every element that makes up our planet and everything on it, was once forged in the heart of a star. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were created billions of years ago in the nuclear furnaces of stars that lived and died long before our sun was even born. These stars, at the end of their lives, exploded as supernovae, scattering their enriched guts across the cosmos. These stellar remnants eventually coalesced into new stars, planets, and ultimately life itself. We are quite literally stardust. We are the universe made conscious of itself. Outro and everlasting voyage. As we conclude our cosmic journey, remember this: the universe is not a static, unchanging backdrop to our lives. It's a dynamic, ever-evolving tapestry woven from the threads of space, time, matter, and energy. Every atom in your body has a cosmic history, a story that stretches back billions of years to the Big Bang itself. We are part of this universe, and it is part of us. As we continue to explore the cosmos, we unravel the secrets of our own existence, uncovering the profound connections